Hello everyone and welcome to another stream. So today I decided that I'm going to take some of my Raspberry Pi data that I got last week when we had a huge heat wave here in Oregon, and I'm going to try to process it. So just a couple of disclaimers here. This may not work. And I'm going to start doing this disclaimer on every stream that I do. Sometimes the things that I attempt to do are not going to work. So earlier this week, I tried to show everybody Pop! OS. And I was so excited, but I didn't try installing Pop! OS on VirtualBox on Windows. So I spent the entire stream basically trying to get Pop! OS to work. It didn't work. And then I dumped it over to Linux the next day and got it to work and showed everybody what I wanted to show them. So, standard disclaimer, this may not work for several different reasons. One of those reasons is, so I've got a bunch of data, and I'll explain where it came from and all that, but I've got a bunch of data. I'm going to attempt to put it all into one database. So I've got 4 different streams. I exported them into a CSV file, and I'm going to try to get them into a single database. And I've decided that I'm going to do that with Golang. Now, this is usually something I would do with Python, and I created a video a while back on using Python and Sqlite together and how great of a combination that is. It's usually how I do this, but I haven't done anything in Golang in a while, and I'm getting a little rusty. So I've decided that I'm going to do this in Golang, and I don't know 100% if this will work. I'm going to take I have some notes. I have some old software that I've written that I can pull from if I need to, but I'm not really 100% sure this is going to work. However, what I want to do is take this data into the software. One other thing you may have noticed, so a lot of the streamers out there say to run your stream starting thing for 5 minutes to let everybody know that you're getting online and you're going to be streaming and etc. And that's what I've been doing for a long time now, but I got a bunch of emails and I got a couple of people that told me in person, they're like, hey, I tried to watch your stream and all I saw was stream starting. It was confusing, so I closed it. So that's definitely a problem. It's an issue. So rather than having the stream starting thing go for 5 minutes so everyone can go on, I will just sit here and babble for a few minutes so everybody can go on. Because I don't want people closing out. Most of my streams are not viewed live. That's one of the things I've noticed. If you look at my Twitch and my YouTube, most of the time people view my streams after the fact, after they've happened. So instead of running it for 5 minutes to let everyone know that I'm on, I'm just going to hit play like I did this time. So let's go ahead and dig on in. Let's switch the camera here. Perfect. And you may notice today I'm on my Mac M1. So my Arch Linux machine, I was going to do this on my Arch Linux machine. However, when I stream to that, I can't get chat to work. So here we are. I'm going to do this on a Mac. I think everything will work. So I have done some Golang on this Mac months ago. Everything worked great. So I'm thinking it'll work great now. It's been kind of surprising. I've done .NET Core stuff on this Mac M1. I've done some Golang. It all seems to work. Oops. So we're going to make their hot car. Okay, now I'll show everybody what I'm talking about. If you haven't gone to my streams, you have no idea what I'm talking about when I talk about this Raspberry Pi thing. Here we go. So we had this huge heat wave that came across the Pacific Northwest. And it really hit Canada and places like that hard. But what I decided to do was take this Raspberry Pi here and I put it underneath my deck in the shade so that it wasn't in direct sunlight and there wasn't a lot of wind going across it. That was the big thing. You can see these rafters here were kind of blocking the wind. So I figured that would be a pretty accurate way to grab temperature and humidity while it was outside. And I noticed I kept checking back and forth. So our nearest weather station is about 10 miles away from me. So that's what I was checking against. It's over in the middle of Forest Grove. I'm way out here in Gaston, so I kind of went back and forth and checked it, and most of the time I was either on point or within 1 degree, 2 degrees of what the weather station was saying, so I figure this is pretty accurate. Now, another thing that I did here, and I piped this into Adafruit.io, and actually I still have it up and running right now. As you can see, it's 83.5. It's not a heat wave anymore, but as you'll see here, we got pretty hot. So I decided to do the temperature and humidity there. Then the next day, I decided to take our car, and I put something, another Raspberry Pi with another temperature sensor in the car. And as you can see here, we reached 170 degrees. So the first day, rolled the windows down a little bit. Second day, rolled the windows up. It was really hot inside that car. So what we're going to do is we're going to take some of that data. So I've got a lot of that data out here, and I'm going to analyze it, and we're going to see if we can get it all into one database so we can really look at it and see the difference between the car temperature and the outside temperature. That's what I'm hoping for. And I just noticed, there we go. So I've got some music playing here, but it is not playing over a standard like line in, because we're on the Mac, the M1. Things are a little different here. So with all that fancy context, we're ready to go. So I'm creating a directory here called hot car. I'm going to bring up my notes. And what I want to do is just write a Go application that's going to read all of these CSVs, and hopefully we'll stuff it all into a Sqlite database. I messed around with it earlier, but I've had a really busy day, so I haven't been able to focus on this super hard. But I'm hoping that I can just dump this all into 4 columns in the database, and then we can look at it and compare. So we'll do that. We're going to use Sqlite. Now we'll go ahead and maximize that. Now here we'll create a new Go app. We'll just call this, and I will put all this code on GitHub. I'll probably name it Hot Car. Got Visual Studio Code, of course. This is how we're going to work today. And we're going to open a folder, or we'll just add folder to workspace, whatever. Jeremy repos. Where's Hot Car? Don't judge me on the amount of repos I have on this system. It's a lot. So let's look at Hot Car here. So far, nothing. We'll create a file called process.go. Now what I'm going to do, I'll explain this a little bit. What I'm going to do is read in these CSV files. We're going to take some data from that. First, I'll read in the CSV, and then I'll display the output. Just kind of make sure that we're reading CSV files and creating output. And then I'm going to attempt to take that output and stuff it into a Sqlite database. Should be fun. I'll go ahead and name this package main. Now, one thing you might notice is I'm using Tab 9 Pro, which I've been really satisfied with, even though I'm a person that doesn't like a lot of things popping up and bouncing in my IDE. For the most part, Tab 9 Pro has been really good. So I've got that going. I don't think I have the GitHub AI thing installed on this machine. I'm honestly not even sure. So let me minimize a couple windows here. Sure, yeah. Streaming, I'm moving, good deal. The first thing I want to do here is we'll add a CSV reader and read in the CSV file. So first we'll put in our func main. Look at that, it's all complete. And I'm just going to copy and paste this code, which actually, I'm not ashamed to say, I have copied and pasted this before for several applications. This is not my code, but it works great. And this is called read CSV file. Now, how this funk works is you pass in the file name, and it returns, as you can see, a string array. And what it does is opens up the file. If there's an error, well, it can't read the file, then it'll spit out that error. And then it does a defer to the file close. And then it opens up a new CSV reader, which, as you can see, we have encoding CSV library here. And then it just reads all. And this is one of the simplest ways in any language to read a CSV file. Which reminds me, I should put the CSV files in there. I'm going to create a folder named CSVs. And then I'm going to attempt to find those. Of course, my mouse is having problems. So I am having some pretty strange problems with this M1 Mac. I don't use it a ton, but if you're using an M1 Mac, you probably know sometimes there's some mouse problems, sometimes there's some UI problems, and when we have those UI problems, I'll show you how to fix them. It's super annoying. All right, we'll dump this. Okay, now I've got my CSV files here. Let's just go ahead and open that up. So here's a CSV file that comes from Adafruit. And what I did was I piped this data in. I think I showed you that here. And I piped this data into Adafruit, but then I can go and export the data out of Adafruit into a CSV. And that's what I've done. So I've gone through and I exported it at different times because you can't just do a whole bunch of exports at once. So they're a little bit off. Timestamps are a little off. That's fine. But let's take a look at this. This is car humidity. So this is one that was measured in the car. We've got a GUID-like ID here for each reading. Then we've got 12.8, and that's the percent humidity. Then we've got 14856, which is the feed ID, the feed that I was sending it to, and then a timestamp. So what my plan is here is I'll take this timestamp and I'm going to use this as an ID because I've got 4 different data sets here, right? I've got car humidity, I've got car temperature, room humidity, and room temperature. Now it only says room because this is an old feed that I had where I put it in my shop. And so I had room temperature and room humidity for my shop going. But anyway, we're going to take this and we're going to use this as the ID. So each timestamp will be the primary key. And then with that timestamp, we'll have car temperature and humidity, then the outside temperature and humidity. That's the hope with this process here. So we'll make our CSV reader and we will verify that the CSV reader works. And going back to my notes here. And what we'll just need to do is first we'll pick car humidity. So this is the humidity in the car. This is the one that we just looked at a couple minutes ago. We'll start with that one. We'll say records. I think it's read CSV file. And then just pass in the file name, which in our case will be CSV's car humidity.csv. Now this will read this into a set of records, which is a string array of string arrays. I'll show you how cool this is. Whoops. What I generally do is do a range on it. And then in that range, printf, and we'll say, we'll just call this a record. Each row is going to be a record. So record value, and here we'll say records I. We'll see what that looks like. Now, as you can see, I put in the, from the FUMP library, I put in the printf. It's up there. So now I think this thing's ready to roll. Let's try it out. Yep. We'll go build process.go and run process.go. Or process. Unable to read, no such file or directory. So we have csvs carhumidity.csv. Honestly, not sure why this isn't working. There we go. I just needed to put that little dot in there. So as you can see, we're dumping out all of these records. And these are the records that are in carhumidity.csv. Sweet. There's that mouse thing again. Sometimes the mouse just hangs on this M1. I'm not entirely sure why. So one of the things we can do, of course, is we can grab individual fields from this record. And I'm going to put in a new line here so that it's formatted a little better. And the new line does nothing because I have not recompiled. As I said, I'm a little rusty with Go. I haven't done any Go stuff in a while. So we'll go build process go and then run process. There we go. So there's that ID. Here at index 0. There's the ID. What we really want is that value. We'll recompile. And run it. There we go. There's all our different values. There's a lot of them. So one of the things I want to do, actually I want to rename this. Room humidity. We'll rename this one. And we don't have to use room. Let's say outside. That makes it a little bit less confusing. Also, I have no idea how long this is going to take, just as a heads up. Outside humidity. There we go. So now we can go through here and we'll just change some of these values. There we go. There's our outside humidity. As you can see, it got ridiculous at certain points. Let's see what the outside temperature is. There we go. Cool. So we have some float values here. And this is one of the things that we'll have to pay attention to when we're dumping this into a database is what the value type is. This timestamp is a string. We know that. This is a float. We know that. So we're going to have to not only create the right data type in Go, we're going to have to create the right data type in Sqlite. But we'll do that. I've done it before. And like I said, I have some source code here that I can pull from where I've done it before. If I get stuck or confused. It's been a really long week. So I'll just say that right now. It's been a long week. My brain is not firing on all cylinders. However, I think I can still do this. So here's how we can print out all our records. That's great. Now, here's one thing that I've noticed in this data. Which one is the timestamp? 2, 3. Looks like number 3. So as I was thinking about this earlier, check out these timestamps. So we have June 30th, 2021. Cool. And we have 9:05:02. And then we've got 35. And then we've got 39. And then we've got 12. So what I did is I set that sampling rate to every 30 seconds. The problem with that is we've got 2 Raspberry Pis, and both of them are going every 30 seconds, but they're not quite lined up. So if we look at these values, you know, we've got 29, 02, 35, 08. Not only are they not lined up, but there is a little bit of clock drift in there that I've noticed. You know, because theoretically, if you say start at 21, 30 seconds later should be 51. As you can see here, it's 54. And then the next one's 27. So there's a little bit of clock drift there. And I don't really care about that. I'm just sampling every 30 seconds. So one of the things that I will need to do is kind of normalize this a little bit. And we'll take some of these numbers and round them so that they are, let's say if they're under 27, we'll set them to 0. Or under 30, we'll set them to 0. If they're over 30, yeah, that one's a little tricky. Maybe that wasn't a complete thought. But I'd say if they're under 30, I should set them to 0, 0. If they're over 30, I should set them to 30. Then I will have timestamps that all look like they were run every 30 seconds. And I know this is messing with the integrity of the data. I don't really care. It's fine. So what I'll have to do here, now we've got our printouts, and if we change, you know, outside temperature, we'll change it to car temperature. You're going to see another just smattering weird array. So what we can do is we can slice some of this stuff off here. So we'll say, let's just grab that second's value, and then we'll run a test against that value. And I'm going to check my chat to see if anybody's calling me out or saying anything goofy. Nope, looks like we're good. Okay. So we're going to do a string convert to I, and yeah, I'm going to do timestamp. Actually, I'm going to have to grab the timestamp. And I'm outside of scope for this. So let's say the timestamp is, it's in records. Records I3, we know that. Whoops. That was the time where the AI did mess me up a little bit. Okay, records, timestamp. Let's just compile this and run it really quick. Okay, so we've got our timestamp here coming out, and we'll see what it looks like. I don't need to put record in front of it. And we're having the mouse issue again. Yeah, sometimes my mouse just doesn't work. I tried actually replacing the mouse, bought a brand new mouse with a brand new battery. That did not fix it. Tried several different things, but sometimes I just can't move my mouse with OS X on the M1. It's super annoying. So what I need to do is grab this value. The way I can do that is, so I've already started to make this into a slice. I can do the length of the timestamp, two. I only want 2 of those. let's see, when timestamp. Actually, I'll turn this whole thing into a string. We'll make sure and cast this to string, because I think that's very important. See what this timestamp looks like. Expecting comma. So I need to let's see. That's right. I'm gonna actually evaluate this as an integer, however you want to say it. So I want to convert this entire thing into an integer for that, but not timestamp. Let's see. I'm already confused. Okay, so this is the timestamp right here. And let's slice it. And look at that. This thing knows what I'm trying to do here. So the length, we're going to get the length of records I3, which is going to be that timestamp. Slice that minus how many characters? 1, 2, 3, 4 to get it right there. This should give us an accurate version here. Okay. So this should get rid of that UTC, that space UTC. Let's find out. Okay, that got rid of the UTC. So yeah, I got a little confused there for a minute, but here's our timestamp. We're going to remove the space UTC, and then we're going to try to grab the seconds off of that. And I will be right back. I've got to jump. All right, I'm back. So what we've done is we've stripped that UTC off of our timestamp, which is something I want to do. And then I want to grab these last two characters, want to turn them into an integer that I can evaluate and then add back on there. So this is a little confusing and a little weird, but it'll make sense when we're done. So we'll do seconds. Actually, I want to put there we go, SG. We're going to take this, make sure it's a string. We'll grab this. Actually, this might be shorter to just do timestamp. We'll do len for length, timestamp again, minus, we want to go back 2 characters. All right, so now we're slicing this seconds off of here. We'll say if, and check that out, that tab 9 does great. If this happens, we'll log printf error. But now we need to use seconds, right? So we'll do printf. And I'm just doing this to validate that I'm getting the right values here. So we'll compile this and run it. String vert. Is that right? There we go. Okay, now compile it and run it. And I need to put in a line break, new line, whatever you want to call it. There we go. Now you can see here we have seconds and then the timestamp. So what I want to do is modify this timestamp. Like I was saying, if it's greater than 30, we'll name it 30. If it's less than 30, we'll add 00. So basically, we're just basically rounding to 30-second points so that the hope is that we'll get some data that lines up. Like I said, I don't know for sure if this is actually going to work, but that's okay. So if seconds, we'll say greater than or equal to 30. Then, and I'll test this before I run it. Greater than 30. Well, watch this. Less than 30. Isn't that awesome? That's the tab 9 experience. I've been super happy with tab 9. I got the professional version, as you can see, tab 9 Pro, and it does just evaluate your code and figure out what you want. It gets in your way 1% of the time. I will say once in a while it's like, no, I don't want that, but it does little cool stuff like that, so I love it. All right, let's do a little spot check here. It says 05 is greater than 30. Oh, we need to put some more new lines in here so this makes some sense. So we're printing out the timestamp. Let's throw some line breaks in there just because it's kind of jumbled together and doesn't make sense. So this one should say greater than or less than before the timestamp is printed. Greater than 30. Interesting. And I'm just going to take the seconds value in here. Actually, since we're doing a printf, is just going to throw the value in there to make it less confusing. Okay, let's do our spot check. Scroll up here. 19 is less than 30. Yep. 51 is greater than 30. Yep. 55 is greater than 30. Yep. 27 is less than 30. We can see all our little spot checks here to know that we're rounding this thing properly. So what I can do is I will change the timestamp. And I know that this is actually going to recreate the slice, so this may cause a little bit of a performance issue, but I'm willing to do that. So timestamp equals timestamp we'll say length of the timestamp minus, this thing knows what the heck I'm trying to do. So I'm going to take the timestamp, chop 2 characters off of it again, but then I'm going to add. So if it's greater than or equal to 30, then we're going to call it 30. Whoops. That should be. Why doesn't it like that? Oh, forgot. We're talking about a string here. Groovy. And I'm going to jump in the chat really quick because I see some chat stuff, so I don't want to ignore anyone that's in the chat right now. Let me bring up the chat application. Open in browser. Interesting, the restream chat isn't showing me anything at all. So I will attempt to read it off of my OBS screen. Thanks. Mike Carter. Mike, thank you for joining. Holy moly. Mike Carter, one of the coolest and smartest people I've ever met in my life. And he says 2 questions. What is this IDE and what is the language? It's not C# and it's not looking like any Python I've ever seen. Is this the dreaded F#? No. I've been wanting to get into F# for so long. But no, today we're doing Golang, and this is Visual Studio Code. So generally, lately I've just been doing everything in Visual Studio Code. My Python, Golang, even C#. When I do .NET Core. And I just really like Visual Studio Code. And I know that makes me kind of a bandwagon person because every developer out there seems to be obsessed with Visual Studio Code, but it works great. I mean, I have other Go IDEs here. I have Goland, which is really great. It tells me how crappy I'm making my code at times. But this one just kind of stays out of my way and it's easier. And then I have Tab 9 Pro installed here, which is the AI code completion program that I'm trying out and evaluating. And then Mike Carter says, "Oi, Jeremy, you slacker." Always. always a slacker. All the time. So I will jump back in here. Thank you, Mike, for watching my stream. Feel free to critique it like crazy if you want. What was I trying to do here? Oh, okay. So that's right. I'm rounding off all of the values on the end of my timestamp because I know for certain that these 2 Raspberry Pis are not synced up at all. So now let's see what the timestamp looks like. Compile it again. There we go. Now you can see here in my little terminal window that I have a whole bunch of timestamps And I might have a minute issue. Like I said, this is, like I said, I gave the disclaimer at first that this probably wouldn't work. This is just an idea I had in my head. Said, oh, maybe I'll do this. And then I thought, well, I'll round off the seconds because I know the seconds are going to be off, but the minutes could be off too. And if the minutes are going to be off, then we'll have to address that also because it's 2 Raspberry Pis, 2 readings, clock drift like crazy. Just not a really good experience for that. And if I would have had a long enough cable, I could have ran a cable to the sensor that's going into the Ford Focus that was sitting in the heat and maybe synced them up, but probably not. Realistically, probably not. So now we can look at this and we've got all our timestamps pretty close. 0s and 30s at least. So now I've got to stuff it into a database. So what I'm going to do is use this amazing Sqlite database. So I'm going to use a Sqlite database. Like I said, I've done a video, I've done a webinar, some things on Sqlite. I think Sqlite is amazing. I wouldn't recommend you run a shopping cart for some giant shopping site off of Sqlite, but for small data like this, and I consider this small data, I think most people would consider this small data, it's perfect. It's absolutely simple and easy. It's a little like JavaScript in that the types are kind of mushy and things like that, but I really like Sqlite. So that's what I'm going to use to dump this in here. And now I have to remember what to go get. GitHub.com, Matt N, I know that part. And then it's go Sqlite. Let's go Sqlite 3. There we go. And as you can see, I already had it on my machine, but. So let's create a little data layer here. And I will actually call this folder data layer. And I'll create another file in there. I'm just basically trying to keep these things separated a little bit. Datalayer.go. Package. Data layer. Perfect. So for this one, I'm going to want to create a database. I think that's going to be the very first thing. So func create database, name string, that works. And I'm going to use this to create a new database. And that's actually a physical file-based database. That's how Sqlite works. A simple file-based database right here in the folder. So I'm going to look at my notes here. I know I have some notes where I could check if it exists. I've got some code in here that I'm going to dig into. Oh, there we go. OS stat, it even knew what I was going to do somehow. Which I think is crazy. Actually, I'm going to call this DB name because it's a little more explicit than name. So we're going to say DB name plus the .db extension. So if equals nil. So if this exists, we'll just do nothing. In fact, we'll do a log, print line, and say database already exists, pal. I'm super professional with my personal projects. Otherwise, else does not exist. Look at that tab 9 kind of reading my mind here. So here's our create database. Cool, right? So where we need to do this would be probably right in the very beginning. And I'm going to call this new DB. And I'm going to do data layer, create database. We'll just call this one test for now. If error. Let's kill it if it has an error. And if it does create it, we'll say log print line, database created. Test no value used as value. Not really sure what that one means. Let's see if a compiler error gives a little more detail. Test uses the value. Oh, okay, yeah, that's right. So it's returning null right now, and I want it to return a bool and an error. So if it already exists, we can still say true because that means, yes, the database is here. Nil doesn't exist. We'll also return true nil. Log print line. Okay. Why doesn't it like that? Oh. Because I'm returning multiple values. Okay. Now this way it's always going to be true, which is a little silly. But we can say if error then we can return false with the error. I think I have to do else on this one too. I said my Go's getting a little rusty. Okay, and it wants me to return something down here at the bottom, so I'll just return true and nil. And that should work. And it says my database is created. But I don't believe it because I don't see a database. So let's comment out this stuff here really quick. Let's focus now on just creating this database. We'll jump back into reading records later. Yeah, I'm not using that function anymore. Database already exists, pal. Database created. Yet I don't see the database there. So I think I may have it a little mixed up. Let me jump into my old code and see what I'm missing here. I feel like I'm missing something. Jump into I know I have another repo here where I'm tearing into this kind of stuff. Yeah, I don't know. Maybe I don't have old code that does this. I thought I did. Okay, well, I'll just try to figure it out. So stat name DB. DB named, I should not have a test DB. So here, error is nil. Not nil, database already exists. So if it doesn't exist, it should say it does not exist. So maybe my error is here. This should go to my data layer, create the database named test, which should, if we go to create database, oh, we've got to create it. But why does it say the database exists? Going to do this. So if database already exists, return true nil. Database already exists, pal, it says. For OS stat dbname.db. Nothing found for .db. So maybe I need to put in. Not sure why we're getting the false positive on that. Let's do this. Yep, still says database already exists, which is false. So jump into something else here. So there we go. I know I have some code around here somewhere where I've done this before. So I've got current database. There we go. I have a chunk of code here that we'll try. Where it says database exists, skipping creation. This one says the database was created. Of course it wasn't. And then I've got another one here that says else if it does not exist. Yeah, that's right. Then we can drop in this stuff. File, an error, of course. An OS create, DB name, and look at that. We can create it. If there's no errors, or if there is an error, I should say, we'll return false, and then that error. Let's do file close, so we can get rid of those squiggly lines. File closed, undefined. Oh. Yikes, bunch of file calls. All right, database created, it says, and there's our database. Perfect. And I will be right back again. All right, so what have we accomplished here so far? We have created a database. So we've created a Sqlite database here. Let's open it up. Hot car. Nothing here. Literally nothing in here. So we'll close this. That's fine. And we're going to do some stuff with this database. So this is the database that I'm going to store all these values in. Now, one thing I need to do is I need to create some tables. And then after I create the table, I'll need to insert a list of values from that timestamp. And we may have to round the timestamps. We definitely had to round seconds. We're probably going to have to round minutes, I'm guessing, just by looking at some of these. So let's look at car humidity. We can see 2014, 2014, 2015, 2016. Let's look at outside humidity. And these don't quite line up no matter what, but there is no 2014 in here, is there? Oh, there is a 2014. So we might be okay. We'll see when we get there. Like I said, this one isn't really a carefully crafted planned presentation. This is just that I'm going to sit down and try to do stuff. So now I need to create a table. And I'm going to do that again in my data layer. Whoops. Create table. Look at that. Tab 9 knows create table. And it's even asking for the DB name for a string, but I can't do that. I've got to pass in the database as a pointer, so I can't do that. I have to pass in SQLDB like this. And I'm going to do the bool error again for this. And what kind of table do I need to create? Let's look at our data. So the only thing I really care about in these tables are two things. I care about the timestamp that's in here, which is text, and I care about the value. I don't care about this ID. I don't care about this GUID index here. I only care about those two things. This one's clearly a float. This is clearly text. So if I want to get car humidity, car temperature, outside humidity, and outside temperature, I'm going to need all of those values in floats and then attempt to tie it to text. So let's start that. Create reading SQL. In here, look at this, tab 9 and Visual Studio Code both suggesting some things. Create table if not exists sounds good to me. I want this to be capital reading. And then I'm going to have to put in some values. So we want timestamp. And we want timestamp to be text. Then let's just go down the list here. Car humidity. Float. Or no, float 32 is not. I think it's just float. We'll find out. Car temperature. Float. Outside humidity. Float. Outside temperature. Float. Okay. That should work. Except we don't want the trailing comma. We don't want any text. Why is this thing barking at me? String literal. Yeah, it's got to be a string literal because of all those silly double quotes in there. There we go. Now the error is declared but not used. Oh, trust me, we will use it. So now we have create reading SQL. Let's go ahead and create a statement. Look at that. Statement, comma, error equals. This is great. db.prepare. Both tab 9 and Visual Studio Code knew I was going to do a db prepare off of this. And of course, if I do if error, if there's an error, what are we going to do? We're just going to print a line that says failed SQL statement. Or we could say something a little bit more explicit. Failed to create database. That's a little bit more explicit, a little more fun. And then we can exec it. probably run exit top of there, but we'll say, and we still need to return true, so okay, so create table should, this method should create my table. And let's just kind of go back and look at it here. If you're not a Go programmer, I'm barely a Go programmer, or you haven't messed with this kind of thing before, this might be kind of helpful. So what we're doing here is we're creating a table. We have to pass in the database that we're going to create a database connection over here in process.go, and then we have to pass that in by reference. And then these are the return types. We're going to return bool and an error if the error exists. Create reading SQL just says create table if it doesn't already exist, named reading with timestamp of text, car humidity is float, car temperature is float, outside humidity is float, outside temperature is float. Ostensibly, this should work. So, if this one says database created. Yeah, so that means it's there and it's good to go. So we'll just put it in here. And here we want to do data layer, create table. Oh, we got to put that in there. That's right. Create database. Got a couple messages here. Okay. So what we need to do is create a database connection. And I'm going to name that dbcon. And look at that. It already knows to go to that data layer. Right? But actually, we're not going to do that. We're going to go to SQL open. And we don't want MySQL, we want Sqlite, comma, and maybe I should extract that name, this name that's up here. Let's go ahead and abstract that. That way I don't have to repeat it over and over in a bunch of different places. This is where our DB name should go, plus .db, because I'm adding the extension later. And yeah, of course I should. Just do this for now. So new table, we'll catch the error, equals data layer, create table. And of course, we're going to pass in dbcon. Nope, just dbcon. If error not nil, we can say log fatal, I guess, for that one. And an if new table. Table created, look at that. It already knows what I'm going to type before I type it. It's amazing. So in here, if we have a database, so if there's no database, it'll create a database. If there's already a database, then we're going to go here, right here, line 21. And we're going to say database created or exists. Let's update that a little bit. Then we're going to make a DB connection with SQL Open. We're going to use SQLite and then the name of the DB. Then for new table, we're going to do data layer create table dbcon. If that fails, we'll drop out with a fatal error, log it, kill everything. If it works, then we'll just put table created. Let's compile it. There we go. We've got some issues here. So let's scroll up to the top. Invalid memory address. I haven't really received this one before. Wonder if it's that reference. This problem that we had earlier. People like using full paths with this stuff. I don't like using full paths. It's not my favorite. Nope, still doing it. So we can't create a table. And I don't have the table open in DB browser. Database. Created or exists. Runtime error, invalid memory address, or nil pointer dereference. Let me check some of my other older code. DB, SQL.db. I'm just going to look through all this stuff. Got our SQL statement. Create table if not exists. And actually we can let's just dump this in just to spot check it. Let's open up. Come on, mouse. Cooperate with me. All right, so we'll open up test.db. We've got no tables. Let's throw some SQL. Jeez Louise. Go to execute SQL. Executed successfully. So we were able to create this table. There's our reading table. Cool. So I'll close this database. Don't need to save it because I'm going to delete it and we're going to start with a new database. So we'll delete, move to trash, and I'm going to try to run this again. Go build process go, dot process. Still doesn't like it at create table. Invalid memory address. That's where it panicked. Invalid dereference. So let's look at this really good here. See if we can catch it before. Maybe it's not. Maybe it's something weird with the way it's creating this connection. There we go. Unknown driver, SQLite, forgotten import. That's going to be in data layer. There we go. So we were able to create that file, which, so as you might have deduced, if you're very familiar with the Go world or you've done these types of things before, my create database really probably just created a pretty much empty file. So if we look at it here, we open this database, it's nothing, right? So it just kind of created an empty file and said, this is whatever.db, go do something with it later. So what I need to do is drop in my GitHub reference here, github.com mattn / go Sqlite 3. I think this will work. Saving. Is this going to work? Let's find out. I have no idea why the saving is taking so long, but look at that. And I have seen this before with Camtasia, but I've never actually seen it with Visual Studio Code. So this freaking M1 Mac has been a process. I really like it. I think it's pretty cool. At the same time, there are some issues. Like I wouldn't want to use this every day for work or something because it has some interesting bugs. I'm going to go ahead and cancel this. And I believe I did a go install way up here. There it is. Go get mattn go Sqlite, and it's Sqlite 3. So yeah, that is a little bit of a weird file system thing that we just experienced together here. Usually, you know, on any machine made after the 1980s, when you press save on a text file, it just saves. It was taking a little long there, so there was obviously some kind of hanging process. That's fine. I still recommend the Go, or the, Go. I still recommend the Mac M1 for most people. I think it's really cool. Unknown driver, Sqlite. Does it need to be Sqlite 3? Probably. Honestly, don't remember. So, let's see. Statement exec. Where did we create that? That was in process. Is there 2 L's in Sqlite? I don't think so. Nope. I'm going to guess it's Sqlite 3, actually, because I just had to do that with the import. Go build. There we go. So this is like another example. I love to prepare for talks and presentations and be super ultra prepared and do really good. What I like about live streaming is when I'm not super prepared and super good, you can see my mistakes and you can see that every developer makes mistakes. I definitely don't want to sit up here on a podium and be like, I am the greatest programmer in the world and I never make mistakes and watch me work. That's not me. I make all the same mistakes you do or more. I just really like this stuff and really like sharing it with people. It's fun. It's fun to share stuff and it's fun to teach people. So if I'm teaching you something that you don't know, that's super fun to me. If you teach me something that I don't know, that's also super fun for me. So that's why I do this. It's not the fame and fortune. So now we've got a table. As you can see, we have timestamp of text, car humidity, temperature, outside temperature. We have all of the fields that we thought we were going to have. And I'll close this out. And of course, this is idempotent. I can sit here and run it over and over and over. It's not going to do anything because the database exists. It's not going to create a new one. Table exists. It's not going to create a new one. Yet if I go and delete this and run it again, it's going to create the testDB with the new table. So now I need to install my first set of records. And what I mean by first is these are going to be the records where we're going to use the timestamp as an index. So these were all taken at different times, as I've said, but we're going to try to match them up by that timestamp. Try to. No promises. So what I should probably do is find the one with the most records in it. This one has 8,366. This one has 8,364. Let's see. Ooh, this one has 8,899. Whichever one has the most records, that's what I'm going to start with. Okay, so it's outside humidity, has 8,899. So let's jump back into process. .go. And when we open up our records again, which we're going to do, we are going to want to write outside humidity. Okay, now what I want to do, think about this for a minute. I think since this one has the most records, it makes the most sense. What I think I want to do here is grab this timestamp, insert it, use it as the record. Let's see when this one, outside humidity, starts at 1636. I could probably do all of this with a SQL statement if I was better at SQL. 1636. Yeah, 1636. Car temperature is definitely going to be different because I started it later. So yeah, it's going to start a little bit later, but that's fine. We're just going to try to kind of capture this. And now that I think about it, instead of trying to get the most timestamps for an index, I should probably actually go with the smallest one, because the smallest one is the only one that's going to have all 4 values. So now I got to remember which one's the smallest one. 8366. This one's 8364. This is probably car temperature is where I want to go, because that's the one that's going to have the least amount of values, but it's the only one that should have 4 values, theoretically. Going by theory here. Just wanted to test out that button. All right, I will be right back. All right. We're back. back to the desktop view with the camera. Check this out. I got two cameras. I'm not sure. Basically, I got this other camera here as a backup camera, and I got it for filming when I'm doing like pre-produced type shows where I could just talk into this camera and then go over here and talk to this camera. But I don't think I'm actually going to do that very much. So basically, I've got two cameras, one of them which isn't used much. However, it's always good to have a backup. I have one expensive fancy camera that you're looking at right now, and then I have one not so expensive, not so fancy camera that's actually identical for streaming. Like, you can't tell the difference between these two cameras when you're streaming, right? It's only in the produced stuff, the 4K stuff, that you really notice it. So, where were we? We were opening up a database. We're creating a table. So if we have a database, that's what this is here. Comment. If we have a database, game on. Then we'll say, let's connect to it. Let's create a table. So now we're good. I'm just kind of removing some of the gunk out of here and just adding some comments. I'm going to share all of this on GitHub. FYI, I'm going to share these data sets on GitHub. And my hope for that is that you will download it and play around with it and mess with it and see what kind of stuff you can extract from that data. And you might do a better job than me, and that's okay. I'll be totally cool with that. So, if new table, so we'll just say, if the table exists, then we can do stuff, right? So if the table exists, we'll just say table exists. So that's basically saying it was either created or it was already there. Now comes the fun part. Now we get to do an insert. And again, I'm going to look up something I've done before. So this one, I think I'm going to call it first insert, and I'm going to put it in my data layer. So now we can collapse, create database, we can collapse, create table. We've got both of those. Now we have, let's see, we'll call this first insert, right? We'll do the bool error there. Now, one thing you'll notice I'm doing that's a bit redundant is I'm going to drop in the database again. And there's probably a better way, like if I were really doing this for a production application and really thinking about it, I would just probably find a way to persist it. So I'm an object-oriented guy, you know, and I'm doing Go right now, which isn't very object-oriented, but I'm just an object-oriented person in my brain. And sometimes it's hard to unwire that, but the object-oriented programmer in me definitely wants to make this data layer a persistent class where I connect to that database once and then persist that across everything and then close it when I'm done. I'm not going to do that today, but just sharing. Now for the insert, we did talk about what we wanted to do with that insert. We wanted to insert the timestamp, which is a string, and then we wanted to insert the value. We'll just call it value. And that value is a float. We're going to say float 64. So now when we call this, we're going to call this the first insert. And the reason I'm calling it first insert is because this first insert has to install or has to insert that timestamp, because that's what we're going to use as an index. The next inserts after that are simply going to look for that timestamp and insert the value that goes with it. that makes any sense. If I'm not making sense, feel free to jump in the chat and tell me that I'm not making sense. Tom Massey, coming to visit me. I like pie. Cherry pie? Thank you, Tom, for coming. You missed Michael Carter earlier. Pretty cool. My old Sure ID peeps checking in. So first insert. Let's rig up that first insert. So we're going to make some SQL here. We'll call it insert reading. What the heck? See, I've done insert reading SQL before, and tab 9 picked up onto that. And it's picked up that I want to insert into reading. But what do I want to insert? Do you know? Oh, yeah, you do. Kind of. I want to insert into reading timestamp. And what one did we decide to go with? Was it car temperature? Yeah. So where? Just gonna make sure that car temperature is the one that I'm reading. Yeah, car temperature.csv. So car temperature is the temperature that's inside the car. Car temperature, not car humidity, just car temperature. And values, question mark, because this is going to be a prepared statement. That was odd. So here's our insert reading SQL. Insert into reading, timestamp, car temperature, values, blah, blah. Let's do a statement. Is it going to do a DB prepare for me or DB prep? Right now I'm just kind of messing with tab 9. Oh, look at, there we go, DB prepare. Cool. Let's prepare the insert reading SQL. I should probably be consistent with this. If error is not nil. Log. Print line. Failed to prepare SQL statement. Sweet. And then, of course, we'll execute it. So we'll do statement, actually. Look at that. It knows what I'm going to do. Statement exec, and I need to pass in the timestamp, the value, right? So these are coming in, these are being passed into the method. String of timestamp, value, which is float 64, is going to be installed here and here. If that errors out, we'll say log print line failed to insert data. And I'll probably, actually, if that's going to happen, I want to know what it tried to insert. So just put do printf instead of print line, and we'll say timestamp /n, and then we'll say value. We'll do a new line after that. And then timestamp and value. That way, see, print line in Go, print line just prints a line of text, whatever text you put in there. And you can concatenate that. You can mess with that string, whatever. Printf is a lot cooler for things like this, where printf will say timestamp and then %v, that's your value identifier. that's just going to print the value, whatever it is. It's not going to be a string. It's not going to be an integer. It's not going to be whatever. It's just whatever the value is. So if we have an error, we can just dump the timestamp and the value to see what that was, to see if that caused the error. And I think this is all I need to make it work. Let me see what the little squiggly's about. Missing the return. So on this method, I'm returning the Boolean error. So I need to be cognizant of that. Return false and error. So if this fails, then we're going to return false, that it didn't work, and we're going to throw the error back to it. If everything works, then we get down here and we'll say return true nil. This first insert, I think, will insert our data. Let's see. Then we're going to uncomment records again. I'm going to remove some of these line returns. We don't need this much. Sometimes I do this when I'm demonstrating code, like in my courses and other videos. I like to put a lot of white space in there so you can really see kind of what's going on, but then later, of course, we gotta pull it out of there. See if there's anyone in chat heckling me. So far, no. All right. A lot of people on Twitch. So one of the reasons I've been streaming so much this week, if you like what I'm streaming, if you like what you're seeing right now, I'm going to do more of this stuff. Please follow me on Twitch. So a lot of the reasons I've been streaming a lot this week is because I'm trying to get affiliate status, and I'm almost there because the more I'm streaming on Twitch, the more people are joining, you know, and getting a lot of people joining and also getting a lot of people watching it after the fact. So that's kind of encouraging me to do this more. I'm not trying to become affiliate or partner on Twitch just so I can make a bunch of money. I'm trying to do it so that I can maybe join some coding teams and guilds, and I can do raids and all these different things. So that's something that I'm trying to accomplish. I should be able to accomplish it here in July, because I think I've met a lot of the thresholds. And Madam, thank you for joining from Twitch. Is it just me, or does this seem very pixelated for 1080p? That I don't know. You know, I'm looking at it here on Restream, and you're absolutely right. It does look pixelated. So I wonder if I have a terrible video setting. Right now I'm streaming at 1080p, 30 frames per second. The reason I took it from 60 to 30 frames, so my previous streams I was doing 60 frames. Now I'm doing 30 because LinkedIn was barking at me about 30 frames a second and YouTube was lagging, so I changed it to 30. That, however, should not affect the pixelation that looks right now pretty terrible. Pretty terrible. I'm going to jump on actual Twitch here and look really quick. Thank you for bringing this up, because it could be possible that I am streaming out a stream that looks like garbage, which just means I'll have to do it again. Yeah, this doesn't look great. Look at this. This will be like looking into or going into a room with two mirrors in it, right? So this is what my stream looks like right now. Just not great. So I need to figure out why that is. And I'm not sure how many of these settings I can adjust in real time, but I don't think any of them. So my video bit rate, audio bit rate. Weird. So I haven't changed any of these settings, but you're right. This looks pretty terrible. Can I up my kbps? See if this changes it a little bit. Yeah, if you can't read this text, then kind of wasting my time here. So I'm going to see what other OBS settings I can change midstream. probably not a lot. Oh, and it's using a software encoder, which it shouldn't, but yeah, it won't let me change most of the video settings here. Very interesting. So yeah, this looks a little better. There we go. I think upping the bit rate is helping, or it's completely in my imagination. So I'll just keep pumping that bit rate up until I see something break. Thank you, madam. I think I'm saying your name right, madam. Thank you for that feedback, because I was just kind of streaming along, not really paying attention, and most people can't even read what I'm doing here. Okay, back to what I'm doing here. So we have car temperature CSV back in our data layer, and this is my first insert. That's right, I haven't run the first insert yet. So, let's see. And I'm just checking my screen really quick now that the lag is caught up. Yeah, that's much cleaner. And I'm going to change stream beats. I'm going to say it again. Thank you very much to Harris Heller, who is a very prominent streamer and decided to go out of his way and create a bunch of original streaming music for streamers to use. Highly suggest it. I'll show you right here. This is my Spotify. You can go onto Spotify, and this is all copyright-free music to put on your streams. And it's really cool. It was really nice of him to go through that effort and do that. And guess what? He's getting paid for it every time we listen to it on Spotify. So, highly suggest you reward his hard work and use these in your streams if you are also a streamer. All right, I think we're ready to run this. So just to verify, we'll open up our test DB, see if we got anything in it. We do have a reading table. We have nothing in it. So I'll close that. Let's recompile and run it again. Go build. There we go. All right. I don't know what happened there. It seems a little too fast anyway, but nope, still 8 kilobytes, which is what it was a minute ago. So there's still nothing in my database. So let's figure out what went wrong here. Is there any error message? Here, actually, I'll clear it. I'll scroll all the way to the top. I'm a big fan of the terminal and in Visual Studio Code, but as you can see, the terminal doesn't go all the way to the top. So let's go here. We'll clear it. And this is process. We'll do this in a regular Mac terminal. There we go. Database exists. Skipping creation. Database created or exists. Table exists. Error. Parsing TE. What on earth is this? I know what it is. I know what it is. Let me scroll here to... Yep, that's what I thought. I have the headers in my CSV and did not put any check in there. So let's run it again. We'll clear just in case. Now it should be good. Nope, still junk. I thought I knew what it was. You see that confidence that just came out and then just got smashed down right there? But it's fine. I was like, I know what this is. Parsing TE. Still having a problem parsing something, so maybe I just removed it from the wrong one. Car temperature.csv? No, I removed the header out of that one. Save car temperature CSV? CSVs. I'm going to remove the headers out of all of these because if I don't, I'm going to have some kind of problem, right? And I've got another chat here from Madam. If you pipe the output to head or less, you can stick with VS Code. Oh, yeah. I did that earlier. Whoops. And that is a good point that I could just use head or less and then don't have to jump into that. And we'll do that really quick. Show everybody what Madam's talking about. Okay. So you can just pipe the output. Now, I haven't tried head. There's all kinds of little neat Linux stuff you can do in OS X that's pretty cool. So somehow I'm really borking this up. Go all the way up to my Hugo stuff. What am I doing wrong? Parsing TE. Still. So I might just have to output and see. Opening up .csv's car temperature.csv. This should be a perfectly fine file at this point. Let's just do a cat on it really quick to see. It's cat. So this is totally that first line. So I'm not sure why it's doing this. Let's recompile, right? That's always the answer. .csv's car temperature. No, it reads in records. And I'm just going to start, doing what we do as developers. You just start printing crap out, right? Let's print out the timestamp. print out seconds. Actually, I'm going to do printf again. My favorite printf because I want to format this a little bit. Sometimes the good old-fashioned we got here type debugging is great. Printf debugging, console log debugging, whatever you want to call it. I tell you, when I write JavaScript, I do a lot of console logging. Database exists, table exists, and then it dumps out a bunch of these. Very interesting. These timestamps look great, other than the fact that they're not rounded. The seconds aren't rounded like they were before. I'm probably printing it out before the rounding. Yeah, it is printing it out before the rounding. Oh, that, and I haven't even inserted this, have I? Oh man, I feel super smart today. Not inserting it, I'm just printing it. So that's why it's just printing and not inserting into the database. I is super smart. So what I need to do is do the insert value. So we'll do, actually, data layer, insert. We want first insert. I tried to let the tab 9 autocomplete it, but it kind of failed on me there. It's fine. dbcon. There we go. And we need a timestamp. We've got a timestamp. And then we need the value, which our value is going to be C. I don't know if I'm actually pulling value out of here yet. So value is going to be, if we're at car temperature, it's going to be number 1. So I probably should be extracting that value. We'll have to extract it into a float. So I'm going to pull this out of here. Come on, mouse. Oh, I think I'm having the UI problem. That's what I call it, the UI problem. Here's how you fix the UI problem. When you have weird stuff, you have menus that you're not able to get to or things you're not able to click. You go in here, you go to displays. You set scale. This is so stupid. But this is a Mac M1 thing. Then you go back to default. And then all of a sudden you'll have all your menus back. Your mouse will behave normally. It's silly. So for this value, I'm just going to call it R value. And this is going to be records 1. I'm going to go ahead and throw some error checking in there. Oops. It's been a long week. Look at that. It already knows I want to do a string convert. Because I did it earlier. And I don't want to parse an int. I want to parse float. And then I want it to be records 1. And we want that to be a 64-bit. That doesn't really need to be, but it'll be fine. And then there we go. Our value. Sweet. See why it doesn't like that. Undeclared name. I declared it up here, didn't I? Oh, that's right. New DB is what I named that. I think is what I called it. Oh no, I need to we need to create this. Yeah, I'll need to create a DB connection. It was actually suggesting that. So DB connection error. This is going to be SQL open, right? .db. So we are going to need a database connection in here in addition to the one that's in our data layer. In order to do this, I believe. Let me think about this for a minute. A little text from my wife. So do I need to pass in? So I created this data layer. And I created this first insert. Yeah, I do have to pass in this database connection, which I thought I created in here, but oh well. So we'll create this. If it's not nil, we'll log it. And then we'll pass it in down here. This should work. We'll say if result log print line success. I'm probably not going to want to print success on every single one of these, but we'll see. Like all of a sudden everything seems out of scope. There we go. Our value result doesn't like this. The value of error is never used. If error is not nil. Part doesn't need to be title case. Convert value. And then here we'll say if it was null, print line could not insert. All right, I think this is all we need. Let's find out. Let's compile. Now let's run. Success. And I could see, I don't know if you caught that, probably not, but there was a testdb.journal that popped up here, so I'm thinking that this actually worked. Just because I saw that temporary file being created. Yeah, 287K. Bam. What in the heck are those values, though? So it inserted values, but yeah, not the right values. Which is fine, because we can just delete this and start over again. But I do need to figure out why on earth. And this value, 16548, has been posted for every single one of these. So I'm going to Google really quick and see what the significance of that number is. I don't know off the top of my head, but I feel like it has to be significant. 1654845. It's got to be significant. No, it's a fuel filler neck on eBay and a DOT number for school time transportation. Okay, well, I thought there would be some significance to that number. There's not. So let's figure out why this is happening. I'll close the database. I'm going to delete the database. Delete. Move to trash. So we're going to have to start this over again. So let's just kind of step back and walk through the stuff here. 1654846 indeed is the ID. Yeah, I am super smart, right? That is the ID number, so it just posted the ID number instead of the value. And I thought I selected it as 1. And I see another error that I forgot to handle. And obviously I should push this out into a method, but I'm just goofing around today. So let's scroll down to where I'm dropping in these values because I'm dropping in the wrong one. Oh, right there. Look at that. Records 2. So, yeah. Probably shouldn't be so confident, right? Sometimes. There we go. Now we're in index 1. So I had index 2, which is this ID right here, and it filled the entire table with that ID. It did exactly what I asked it to. I asked it to do the wrong thing. So let's build it again. We'll process it again. See, there's that testDB journal right there. It's like a temp file that comes up. Now let's see what our values look like. They should look a little better. There we go. That's a little more like it. These are the temperature values. I'm not even kidding. Look at this. 130.28. No problem in that car. We went even hotter than that. So let's step back and look at it a little bit here. We have our timestamp that's rounded to 0s and 30s, which is great. We're going to need that. And we have the car temperature value. And it looks like, because this is all from the same CSV, it should all be here. And it looks like it's all here. And check this out. We can actually look at the temperatures. We'll go select. And it's values, I believe it was. I got to look at the database structure again. Select car humidity. Or not car humidity, car temperature. So we'll select car temperature from reading, right? Order by car temperature. Descending. Look at that. There's the top temperature out of the 2 days of reading. Believe it or not, 170 degrees, which is wild, right? And it was all kind of during the same time, but yeah, it got up to 170 degrees in that car. And it was also very, very hot outside. I think during this time, I think it was like 117 outside. And what I did was I parked the car in the sun. So I didn't put the temperature sensor in the sun. I put it inside the console, inside the car, because I didn't want the sunlight to affect the overall temperature. So I put it inside the console of the car, and then just left the car for a couple days, sitting out in the sun. There's no shade. It's parked away from my house. It's parked away from any trees, so there was no shade on that car whatsoever. It doesn't have tinted windows, so it was just sitting in there baking this Raspberry Pi, and that's how we got this 170 degrees. So now that we look at it, now I just need to put in the car humidity, outside temperature. So I'm glad that we've gotten this far in a couple hours. It's pretty sweet. Check my chat. All right, Madam's asking, how come you're not sending the logs from a Pi to a DB right away? That's a great question. One of the reasons is I did this in a hurry. So the heat wave hit, and my wife said, hey, you know what you should do is set up those little Raspberry Pis, because I've done this a bunch of times where I've set up Raspberry Pis with temperature and humidity sensors, the lumosity sensors, sound sensors, stuff like that. She's like, why don't you set that up? So I'm like, oh, I better hurry, because we were at the first day of the heat wave, and I knew that it was going to get super hot, and it was like 9 in the morning or something. So I just put it together, wrote some quick stuff to spit it out to Adafruit, and I figured I could grab that from Adafruit later. What I should have done, had I had more preparation and more time, is just logged it to a database. Like you're saying, just logged it to a Sqlite database on the Raspberry Pi, which I have done before. And it's actually very easy to do that also, where, you know, everything runs in Python to grab these sensors. And so you can just insert Python to save that stuff to a Sqlite database. But basically it was just time. Like I was in a hurry, wanted to hurry up and start collecting data before it got hot, because all the news people were like, it's going to be the hottest ever. And it was, but I just had to get it up in a hurry. So I spit it out in some HTTP calls to Adafruit and figured I'd gather it later. And that makes it more fun, I guess, now that I have to decode this and put it back together. But yeah, if I had thought about it a few days beforehand, I probably would have written something a lot better to do this. So we have function first insert. Now I need to create something that's very similar to this, except it needs to be insert based on that timestamp that I'm going to attempt to use as an index. But I don't know if that's going to work. So I'm going to say insert data. And in here we're going to need, yeah, pretty much the same. We're going to need the same input parameters, except I think I'm going to want to put in the table name, because I'm going to need the table name for the insert statement, I think. So we'll do this. We'll do table name as string as an input parameter. Now, why is this thing barking at me? Oh, because I put the comma in the wrong place. Okay, so now insert data, we're going to insert it in, or not table name, column name. It's been a long week, like I said. Okay, so now we're going to insert it into a specific column name. We're going to insert the timestamp again and the value again. But this time, instead of using the timestamp as an insert, we are going to use the timestamp to look up the row to insert into. And this is all stuff that's just floating in my head. I've never done this exact thing that I'm trying to do, but I'm fairly confident that I can do it. So insert, we'll just call this reading again. Insert reading, except it's going to be an update. That's the only difference. So let's not call it insert. We'll call it update reading SQL, because we are going to need to update. Look at that, reading set. And we're going to, let's see, we're going to do we did car temperature, right? Yeah, we did car temperature. So now we're going to do car humidity. And actually, I did say that I was going to break this out. So column name, we want to set column name equal question, and where timestamp equals question mark. Perfect. Declared but not used. I can handle that. So update reading, set column name where timestamp equals, should set that column name that I specify. It should set it to our value where the timestamp. I don't know, this feels sketchy. I'm gonna try it anyway. So we'll do statement, error. We'll prepare that. Prepare a prepared SQL statement. Perfect. And then we're just going to execute this thing. Statement execute. Now we need to take in the column name and the value, because that's what we're going to install, or we're going to insert into these question marks. So we'll say column name, not timestamp, value. So update reading, set whatever the column name is. That's right, I don't need to do the column name here. I need to do the value where timestamp equals timestamp. So I was being a little too reliant on the AI code completion there. So failed to insert data. Perfect. All right, I need to really look at this here. Missing return. So return false error on both of these. And then down here we'll return true and nil. I feel like I've already heard this song a few times, so let's skip it. And I hate this one. There we go. Perfecto. All right, and it looks like there's a lot of people on Twitch. That's cool. That's cool. It's awesome. All right. So I got my, just making sure all my streams are going through where they're supposed to go. Let's recompile this thing. Let's process it. Ooh, it's going pretty fast, and I see the journal there. I think it did something. I think I have to do the browse data again. Nothing. Let me try closing the database. And I'll run it again. And I just realized something that I probably did. Let me check my code. Did I remember to comment? Yeah, it's did the first insert again. Crap. Okay, so delete this. I love making mistakes live. That's my favorite. I'm actually being serious. I do like making mistakes live. It's like I said, it shows everybody watching that we all do it. So this was that first insert. And actually, I do need to run it again so we can do the first insert. So I'll save it. Go build process, go. Process. Okay, so this should insert that first bit of data that we want. But before I'd inserted it, again. So let's make sure test DB 328. And this goes from June 27th at 8 o'clock to June 30th. Perfect. 8363. That's how many rows we're expecting. That's how many rows are there. Cool. So I will close this. And then I will go and we will comment out this part if I can get the mouse to behave. All right. So now I've got that commented out because I don't want to do that insert twice. Now I want to do result error, data layer. Was it insert data? Yeah. And I should have let tab 9 do its thing. Tab 9, here we go. DB connection. Value, which is going to be our value. Or no, it's column name. So the column name for this one will be, what one are we missing? I believe it was humidity, car humidity. Yeah, car humidity. So I'm going to specify that here. Say car humidity. Then we want to send that timestamp again. And then the value. Now, before I forget, I need to change car temperature CSV to car humidity.csv. Okay. So now I'm going to be inserting it with the database connection into car humidity. I'm going to insert this timestamp to look for and then our value. Could not insert. That works. If result. We'll say inserted our value. All right, I think we're golden. I'm not sure how long I'm going to go on the stream. I've been going on for 2 hours, 6 minutes. That's not too bad. Pretty much going to go until my wife gets home, I think. Which she's texting me. Yeah, as soon as my wife gets home, I'll probably get off here. So it puts a time limit on my productivity. Only because we both work really hard and long hours, and I want to spend my Friday night with her. So I agreed to do this streaming right up until she got home from work. And then I'm out. And I'm not sorry about that. Streaming is fun, but spending time with your people is super fun. So, let's see. I'm going to kind of double check over some of this stuff. I'll look at some of this. So read CSV file, car humidity, inserting into car humidity. This should work. Go build. And I see the journal going there, so it's doing something. Hopefully it's inserting it into the right column. We'll see. It's taking a little while, which is also a good sign. So let's see. Let's open it up. Let's see. 430K now. So yep, there we go. We've got car humidity. Some of them are null. I expected this. And the reason that some of them are null is I just think there's probably like a bit of a mismatch with the minutes, most likely. But I'm okay with that. If you look at this, like most of this data is here. I see some nulls in there. You probably see them too. That's fine. All right, now we just need to do this with outside humidity and outside temperature, and then we'll have a complete, semi-complete database. So I'm going to close out of here, and I'm just gonna cheat with this. I mean, there's no shame. This isn't a production application. This isn't something that I'm selling to you, so it's okay to do stuff like this. We'll say outside humidity. And then I'll change this to outside humidity. And then we'll cross our fingers and hope that this works. Go build process go. Like I said, I'm going to share all this source code with everybody. Even though it's not the greatest, it's not the most beautiful, elegant, magnificent Go code that you've ever seen, but it's working. Oh, the journal's still there. I wonder why that is. Did I forget to close it? I don't know. 455, that's not good. Oh. Maybe it is good. So here we go. We've got some other ones here. So there's our outside humidity. Very interesting, the difference between the humidity inside and outside of the car. I thought that was super interesting. But if you look like right here at June 27th at 9 o'clock, humidity was 100 or 11.9%. Holy moly. The shuffle is not shuffling great today. There we go. So if you look here, the humidity, quite a bit different. 21 degrees outside, 11 inside. So one thing we'll do is our outside temperature. That is the last thing that we need to add. So let's do outside temperature.csv. Save outside temperature. Honestly, I'm surprised that this is all working. Like I said, I'm really rusty with Go. That's why I chose Go. I think I could have done this in twice or half the time in Python. And this is what I usually use is Python for this kind of stuff because there is no big advantage to using Go for this type of stuff. I just was feeling rusty on Go and feeling like, hey, I need to do some Go again. So that's why I wrote it in Go. I'm not convinced that this is any faster, better, or more solid because it's written in Go than it would be in Python or anything else. But it's written in Go. And I'm going to do a lot more streaming with Go and Python, but I think I'm going to focus pretty hard on Go in the coming months because I love the language. It's so simple. One of the things I really like about Go is you can just do a ton of things very fast with it, and it is very fast performance-wise. It's like the best of both worlds. It's like as easy to use as Python, but it's as fast, almost as fast as like C++. If I were doing this in C++, we would probably still be parsing the CSV at this point. So, yeah, fast development, fast performance. I love Go, so I'm going to do a whole lot more Go. So if you're watching this stream and you like Go and you want to see more Go, let me know. Madam says it's the most magnificent Go I've seen. I'm sorry. It's okay, Go, but that's great. And Exist Chills. Hey. I'll just say hey back in the chat. Hey, thanks for joining from YouTube. I do love everybody who's been coming on here and watching my streams. Really appreciate it. This is not like I said, I'm not trying to make money off of this. This is not going to be my full-time job someday. It's just something I like to do for fun. I'm a geek. I like sharing stuff. I work as a developer evangelist at Pluralsight, and it's like seriously my dream job, because I do stuff like write articles, create content, create videos, create streams, create all day long. And my core mission with the company is just to break down problems that people are having in tech. So to use my 20 years of software engineering experience to share with others and help others get into software engineering or get better at software engineering. So like I said, it's like my dream job. So yeah, this Twitch thing is seriously just for fun. And I'm going to do more Twitch stuff with Pluralsight, because we want to build up the Pluralsight channel and of course bring in some of the like top experts that we have at Pluralsight who do amazing work. So there it is. There's all the data all in one table. Tonight, I'm not going to break into this, but I'm going to do another stream. I've decided, since this one went so well, I think on the next stream, if you follow me and tune in, I'm going to say maybe tomorrow, but probably not tomorrow. Maybe Monday. Monday is one that I set aside for .NET stuff, but I think Monday I might do a web app, and like a Go web app will do like Gorilla and pulleys and have an API for it. And I'll like put it on DigitalOcean or Heroku or one of those things. And we'll make an app out of this so I can grab this data. For now, let's just see what our top stuff is, right? That's what people really care about. So I had a Raspberry Pi underneath my deck in the shade, out of the wind. I had another Raspberry Pi inside a 2019 Ford Focus with the windows rolled up. What were the hottest temperatures of each? Let's find out. So we're going to select outside temperature from reading. No, not from real, from reading. There we go, from reading. And we'll order this by outside temperature. I'm sure I could select max, but I'm not even sure. I'm not even sure if select max is a thing with. Oh, there we go. It is. I get my sequels mixed up so much. So there we go. 119.84. Now I tried to change this text. So if you can't read this text, I'm sorry. I tried to change the text size on a stream not too long ago for DB browser, and it blew the whole thing apart, and it put these weird fonts in there. So I'm sorry it's so small, but right now I'm doing select max outside temperature from reading. The top outside temperature that was recorded here in Oregon, I'm in Laurelwood, Oregon, was 119.84. That was the top temperature. Do timestamp. And that was June 29th, 0034. Oh, that's right, it's UTC. I was going to say, I know it wasn't midnight. UTC to PDT converter. All right, so we're gonna have to convert this a little bit. So Pacific Daylight Time. So UTC, that was right about 5 p.m. So at 5:34 p.m. on June 29th, outside was 119 degrees. It was hotter than Oregon is ever used to dealing with. We had roads buckling and cracking. Not even kidding. Like roads were buckling and cracking. Everything was melting. All the plants are dying. Not something that we're used to dealing with on any level. So let's see what the max humidity was. This is a little less exciting, right? We got up to 89.3% humidity. Average day for anybody that lives in Florida. But in Oregon, yeah, it's pretty high. And that was on June 30th. Now, here's what people really care about, right? The car humidity. What's the humidity in the car? The car got all the way up to 55% humidity. Yeah, nobody cares about the humidity. I'm just playing, y'all. The car temperature, which we brought up earlier, that was, it looks like about 602. So probably after the heat wave peaked outside during the day, it peaked, it heated up that car like a little oven, and then it held in that heat for an hour or so. It looks like almost an hour, and it got up to 170.78 degrees. Pretty wild. So what I did was I had my wife start up the car before we started this. You know, I started the day before measuring outside temperature under the deck, and we're like, yeah, cool, everything's great. And then the next day I was like, let's try it inside the car. And so I had her start up the car and run the AC for like 10 minutes, get it to a normal level. It was at 98 degrees, and that's where we started from. The automotive AC kind of failed a little bit. Oh, and I'm seeing I lost my camera, which is probably fine because I have a face for radio anyway. Huh. Well, there's my side camera. That's working. But my Sony camera is not. It's very possible that it's overheating. Oh, there we go. It's back up. Maybe it just glitched. That's actually one of the first times this camera has ever done that to me. So, all right. Well, that's about it for this stream. 2 hours. Like I said, I'm actually surprised this worked. And it's probably not something I should say out loud, but I'm surprised. I just had this idea. I'm like, I'll use Go and stuff it all into this Sqlite database. And it worked. So now I'm going to interpret and analyze it. So I'm thinking of building a Go web app that spits out the stuff in Go. Here, there we go. We'll go to the side view because it's weird to see that black thing. So I will build a Go web app that will access this. We'll put it online. Maybe I'll build a Vue app or a Blazor app. Those are two things. If you don't know me, if you're not following me and you've never met me before, I have a weird set of technologies that I really like, and they're kind of divided along. So in Linux, I love Go and Python and do a ton of stuff with that. And then I also love the Windows side, and I love .NET, .NET Core, Blazor, all of that stuff. So, I'll build a Go web app, and maybe I'll interact with Blazor so we can mix the Windows and Linux worlds like that. Nothing wrong with that. I'm wearing an Azure shirt right now as I've been doing this whole stream, and I haven't done anything with Azure, but I love Azure. So yeah, on my next stream, I guess I'll build some kind of web app to do something with this data. Right now, we pretty much can look at it. I'm going to share this, like I said, with everybody else. Not only will I'll share this database, I'll share the CSVs also, the source CSVs, because you watching may have a better way to organize this data. What I did is I rounded all these seconds off to zeros and 30s. I've got some nulls in here that I don't know why. Like, I don't know why car humidity is null. It could have been a bad sensor reading. I'd have to dig into the CSV. But you may find a different way to take this aggregate data and put it into a single database. And if you do, hit me up. Follow me on Twitter at jeremycmorgan.com. I'm going to throw this on GitHub under github.com/JeremyMorgan. And I will give out this code that we wrote today. I'll give out this data, and you're free to do whatever you'd like with it. You could build out some graphical data representations that might be kind of cool. I might do that as well. Yeah, I don't care what you do with it. I'll give out this data just for anybody who's curious. If you live in Oregon or the Northwest, you remember this wild heat wave, and maybe you want to see what the hottest points were in my little point of the world. I don't know. But thank you, everybody, for for watching my stream. I really appreciate it. A bunch of people on Twitch today. I super appreciate that. Please follow me on Twitch. That's why I put the little banner over here. Look, I don't even know where I'm pointing. There we go. I put a banner over here because right now I'm streaming on YouTube and Twitter and LinkedIn and Twitch and all of these different places, but my home is probably going to be Twitch. There are a few really distinct advantages to just streaming on one platform. It's probably going to be Twitch. So if you like this stream and you're following me on YouTube, or you're watching this on Twitter or Facebook or wherever, follow me on Twitch, twitch.tv/Jeremy Morgan. I appreciate every single follower and every single person today who's come in to chat. I like it. Come in, tell me what you like about my streams. Tell me what you don't like. I can handle it. I got pretty thick skin. I mean, you can just tear it up, throw the criticisms at me, because that's how you grow. It's how you grow as a developer. It's how you grow as a presenter. That's how you grow as everything, is by people saying, hey, it really sucks when you do this. You should stop doing this, right? And then, yeah, I probably should stop doing that. Anyway, thank you very much, everybody who has joined. I really appreciate it. This has been really fun. And follow me, and we'll do it again. I'll be back Monday. We'll be back Monday with something creative to do with all this data I got. And follow me on Twitter, Jeremy C. Morgan. I'm going to post this data this weekend. Thank you, everybody.